This is A2Further Maths. We are on further calculus and we're in chapter 7 here, so we're looking at repeated integration by parts. For regular maths, you need to be comfortable with doing integration by parts. You might have something like x sine x. For further maths, you need to be able to do repeated integration by parts. So if you start to integrate this here, and we would obviously let u equal x squared, dv by dx equals sine x, and work your way through. You then end up with this. This is your uv. Take away cos x. So tidying it up, you get minus x squared cos x plus this. And then at this stage we have 2x cos x, and we can do this by integration by parts. So that's what they mean obviously by repeated integration by parts. So apply method again to this integral. We're going to let u equal 2x. We're going to let dv by dx equal cos x. Du by dx, differentiating here is 2. Integrating here we get us sine x. And we can sub in then from there. So our 2x cos x gives us this. That means our original question, which was x squared sine x, we have our x squared cos x plus 2x sine x plus 2 cos x. A reasonably straightforward thing, I would think, for A2 maths. Let's take a wee look at an example here and see if we can make some sense of it. So we have example 2 here where it says find x squared e to the x. So reasonably standard here, we're going to let u equal to x squared, and we're going to let our dv by dx equal to e to the x. Du by dx is going to give us 2x, and our v of course just gives e to the x. That means the integral of x squared e to the x dx, which was our question, equals uv, which is x squared e to the x. Take away the integral of 2x e to the x dx. This one here is now a slightly easier integration, so we're going to use then integration by parts again for this bit here. We're going to let u equal to 2x. We're going to let dv by dx equal to e to the x. Du by dx is 2. V is e to the x. Therefore, the integral of 2x e to the x is uv 2x e to the x minus the integral of v, so is v du by the x, so it's 2e to the x. And we can now integrate this. Okay, so that gives us 2x e to the x minus 2 e to the x plus c. So that is this bit here that we need to take away then from our original one. So down then for our final line there, for the integral of x squared e to the x dx equals x squared e to the x. Take away, and then it's going to be this, is this bit here, so it's 2x e to the x, minus minus there, so we can change that to a plus 2 e to the x, well, plus c. And you might want to factorize out your e to the x, you might not, but that's okay. We have x squared minus 2x plus 2 plus c.